Application of geometric series revolves around compound interest. So I am going to use an example and go through the process to derive the equation for compound interest. If the question straight out asks for investment or depreciation, appreciation of an amount, then you can go ahead and straight out use the compound interest formula. For all other types of questions, such as superannuation, home loan repayments, you actually need to establish a geometric series. You can't just jump in and use a memorized formula. So let's look at this example. We're looking at Frank investing $100,000 at an interest rate of 12% per annum, compounded monthly for 20 years. Now I've made the numbers straightforward just so we can focus on the process rather than the mathematical, messy numerical work. How much will he collect at the end of 20 years? The most important part of this question is this term, compounded monthly. That tells me what I need to be working with. Since it's monthly, I need to convert everything into months. If it said compounded annually, everything needs to be in years as it is in the question. If it said compounded quarterly, I'd need to divide everything by 4 to do the calculations for every quarter. So that's really significant. Let's make a summary of what's given. So the amount invested we call the principal, and that's 100,000. Then we have an interest rate of 12% per annum, which we need to convert to monthly as a decimal. So that would be 1% per month, or 0.01 per month. And we have 20 years, which is 240 months. Okay, we're going to go 1 month at a time and see how the money grows. So at the end of first month, Frank's going to have his $100,000 still in there, plus the interest that the 100,000 has earned. So that's 100,000 times the rate, 0.01, times the time period. Remember, this is simple interest. Interest is simple interest. Principal times rate times number of time periods. So PRN. But since we're doing it for 1 month, it's just n is going to be 1. Now I could calculate this, but I'm trying to establish a pattern and derive a formula. So I'm just going to take a factor out for now. So 100,000, and I have 1 plus 0.01, which I can write as 100,000 1.01. So that's how much money there will be at the end of first month. At the end of second month, well, Frank's going to have what he had at the beginning of second month, that would be A1, plus the interest that now this A1 has earned. So that would be A1 times 0.01. And again, I can take a factor of A1 out. That would be 1.01. Now I don't want to leave it as A1. I want to go back to that principal and write it in terms of the principal. So A1 was 100,000, 1.01. So that's my A1, and now I have another 1.01. So I can write that as 100,000, 1.01 squared. Now, moving on to A3, that would be how much money we had at the beginning of month 3, plus the interest that's been collected over that month, month 3. So that would be A2 times 0.01. Just like before, factorize. So So that I've got 1.01, and A2 was 100,000, and I'm hoping you can see I have 1.01 squared times 1.01, so that's going to be 1.01 cubed. Now, I said before we need 3 terms to establish a pattern for our series problems. So I have my first term A1, and I ended up with 1.01 to the power of 1. When I went to work at A2, I ended up with 1.01 squared. Here's A3, and I ended up with 1.01 to the power of 3. So I'm hoping you can see there is a pattern here. My last one will be A240, and that's going to be 100,000 times 1.01 to the power of 240. So we can calculate that, and that will be at the end of 20 years, at the end of the 240th month, how much money will be there for Frank to collect. So that ends up being $1,089,255.37 to the nearest cent. So that's how I've answered the question, just establishing a pattern. But I said you don't need to. You can just use the formula. So let's see if we can see the formula from what we've done. So to work out the amount after, doesn't matter how many months, we took the principal, multiplied by 1 plus the rate, and the rate was a decimal number, and we made that to the power of however months we had, to the power of n, where okay, so this formula can be used straight out for compound interest equations, for compound interest questions. Would it be appreciation or depreciation? Now let's look at the question which involves depreciation. So Aramis purchases a new car. It's valued at $78,000, and the car, we know it drops in value on a monthly, yearly basis. In this question, it's depreciating at a rate of 11% per annum. Now the question doesn't say monthly or quarterly, it just says 11% per annum, so we can just assume, since they haven't given us any more information, that we can work annually. We want to know how much the car is worth, or how much she can sell it for after 5 years. Since in this case the values are dropping, as opposed to the previous question where the value of the investment was increasing, our formula changes slightly. So our formula becomes amount is the principal, and now we're taking away that rate to the power of n. Instead of adding the rate, we want the values to decrease. So the initial amount is 78,000. Our rate is 11%, so 0.11, and our time period is 5. So I can straight out substitute that in. 1 minus 0.11, 0.89 to the power of 5. And that's equal to $43,555.66 to the nearest cent. Alright, So hopefully you can see, memorizing the formula, knowing the formula, you can apply it to these questions, and the questions aren't very challenging at all.